Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today, guys, we're going to continue with our quadratics, and we've been learning how to solve quadratics, and now we're going to learn how to graph quadratics, and then eventually we're going to finalize this by solving, by graphing, okay, solving any quadratic. So let's get right to it. First of all, guys, hopefully by now you know and you understand that the quadratic function is y equals ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is a constant, or f of x is equal to ax squared plus bx plus c. Please remember that y is the same as f of x. The quadratic function, guys, and again, by now you know this, but I want to make sure that I do a really good job here. It's a U-shaped graph, okay? Quadratics are called parabolas. That is the graph that the quadratic function renders. It is a parabola. Now, the a and the b are coefficients, which we just talked about. The c is the constant. Well, that constant, guys, when it's in ax plus bx plus c form, when it is in this particular form, the c is always going to be your y-intercept. Just so you understand, okay? Now, what does the a do? Well, if the a is greater than 0, okay, it's positive, that means that the graph is going to point upwards. So it goes upwards, always, if a is positive. So if the coefficient in front of x squared is positive, the graph is pointing upwards. If the a, the coefficient of x squared, is less than 0, if it is negative, that means it is opening downwards, okay? So if you're graphing a quadratic function and it has a positive a and your graph is going down, okay, stop, erase it. You know you did it incorrectly, not a big deal, okay? Next, the c. The c is the y-intercept, okay? Remember that. Now, parabolas, guys, are symmetrical. And symmetrical figures are something where they have a line that cuts a parabola or any figure, actually, into perfect symmetrical halves. This line is called the axis of symmetry. Do you guys remember when you were little kids that you would fold a paper, like an art class for Valentine's or Mother's Day? You'd fold the paper, and then you'd draw a half, just a half of a heart, right? And then you cut that out, and then when you unfold it, you had two perfect halves and you had a full heart, right? Okay, that was using symmetry, my brothers. Symmetry. Symmetry in parabolas is called the axis of symmetry. It is a line, and it is found with the formula of x equals negative b over 2a. X equals negative b over 2a. X equals negative b over 2a. The b is the coefficient of the x, and of course a is the coefficient of the x squared. But whenever I want to find the axis of symmetry, I'm going to use the formula x equals negative b over 2a. Excuse me. Now, this line of symmetry, as you can tell, is literally, it cuts it in perfect halves. So, for example, this point right here is 1, 2, 3, 4, 5 to the right. Well, you're also going to have a point 1, 2, 3, 4, 5 to the left. You feel me? This point over here is 7 to the right. This point over here is 7 to the left. The axis of symmetry cuts that parabola into perfect halves. You can literally at this point fold it on top of itself, and every point on the left side of the graph will hit every point on the right side of the graph. The line of symmetry, or the axis of symmetry, cuts that parabola into perfect halves. It's going to be very important for us later, because I'm going to use a term called the mirror image. So when we're graphing, you're going to see, for example, like this point right here. That's the y-intercept of 7. See how the y-intercept of 7 is 1 to the right of the axis of symmetry? Well, if you go 1 to the left, you've got the exact point on the opposite side without doing any math. So knowing this axis of symmetry helps you find what's called mirror images, and that's coming up in a couple minutes. Yes, sir, my brother.
Does the axis of symmetry always have to be on a defined point like 1, 2, or can it be on?
Okay, very good question. The axis of symmetry is not 1, true. The axis of symmetry is an x equals equation. This axis of symmetry in this particular case would be x equals -1. It is always a vertical, imaginary, invisible line. That's why I put a dash on it. It's not really part of the graph. This parabola here did not show you the axis of symmetry except for me defining that it's there. Okay? Does that answer your question, my brother? Thank you, my man. Okay, next, the vertex. The vertex, guys, is the point that is either the maximum or the minimum of a parabola. If we go back here, that's the vertex. That right there. This point right here, that's the vertex. Down here, this is my vertex. Oh, sorry about that. Come on board, cooperate. There we go. That's my vertex. So it's the lowest point or the highest point on the graph. If the A is positive and the graph is pointing upward, I'm going to have a minimum. This vertex right here, that's a minimum because it is the lowest value. If my A is negative, I'm pointing downwards, then my vertex is a maximum. Okay? But to find this vertex, very simple, it's a formula. You take the x value of the axis of symmetry and literally plug it in. So that's why I have f of -b over 2a. Remember that y equals f of x. So whatever the x value of the axis of symmetry is, I'm literally replacing the x in function f with it. So that's what that means. That means take the x value, plug it into the function, and find the y value. That's going to be your vertex. Okay? And again, I explained it again. Simply plug in the value of the axis of symmetry, x equals -b over 2a, into the quadratic function and solve for y, aka your f of x. This I've already explained as well. If a is positive, okay, I'm going to have a minimum. I'm going to have a minimum. If a is negative, I'm going to have a maximum. Okay? So if my a is positive, that means that my parabola is pointing upwards. I'm going to have a minimum. It's going to be the lowest possible value. If my a is negative and I have a graph that's pointing downwards, I'm going to have a maximum. It's my highest possible value. So now just wrapping it all up, what does the graph of a quadratic function y equals ax squared plus bx squared plus c, in other words, a parabola, look like? What are the significant parts? Well, here it is. You have your parabola. You have your vertex, very important. Vertex is your max or your min. Your vertex is found by finding your axis of symmetry, the -b over 2a, plugging it into the function, and finding your y value. The y-intercept. The y-intercept is the y value when x is 0. Okay, it's the c of the graph. That's my y-intercept. And then I have, of course, an axis of symmetry, this dashed line right here. My axis of symmetry is x equals -b over 2a. Are there any questions on what we have discussed so far? Yes, no, maybe, kind of, sort of? No? Okay. Let us continue then. Thank you. All right, guys, so now let's graph it. Let's put it all together. That's all nice and good, Mr. Moore, but how do we do it? Well, let's go step by step. I want to graph f of x equals 2x squared minus 8x plus 9. First step, guys, axis of symmetry. So my axis of symmetry is x equals -b, in this case, it's going to be +8. over 2a. So x equals 8 over 4, which is 2. And what I like to do, guys, is I like to graph the axis of symmetry immediately. Step 2. I got to find my vertex. So I use the x value of the axis of symmetry, which is 2. And I literally plug it in to find my y. I want to find my f of negative b over 2a. So in other words, I want to find f of 2. So plug it in. 2 times 2 squared minus 8 times 2 plus 9. 2 squared is 4. 4 times 2 is 8. 8 minus 16 is negative 8. Negative 8 plus 9 is 1. So I'm going to go ahead and graph my vertex. 2, 1. Step 3, y-intercept. Well, my y-intercept is the y value when x is 0, or the c value. And in this case, the c value was 9. So 0, 9 is my y-intercept. So once I put my 0, 9, it's right here. Now I do the mirror image, guys. So if that's 2 places to the left of the axis of symmetry, where would the mirror image be? 2 places to the right. And you are done. Now, there is a step 4. It's an extra point and it's mirror image, or you can find the x-intercepts or the roots by locating them on the graph, solving using the square root method, which we know how to do, factoring, which we know how to do, completing the square, which we know how to do, and quadratic formula, which we know how to do. Now, this step 4 is sometimes needed, sometimes it's not. So let me explain when it's needed and when it's not needed. If by chance, and actually let me do this. If by chance the vertex and the y-intercept are exactly the same, you have to do step 4. What am I talking about? Let's say I tell you graph y equals x squared minus 3, let's just say, okay? My first step, axis of symmetry. My axis of symmetry is x equals negative b, which is 0, over 2a. So in this case, my x equals 0. You with me? Let me get my little graph here. Okay. You'll see, yes there is. You'll see. Step 2, so my axis is 0. So when x equals 0, it's right on the y-axis. That's my axis of symmetry. Step 2, my vertex. Well, I'm going to plug in my x value from the axis of symmetry and find my y value. So I got 0, negative 3. So 0, 1, 2, negative 3. And now, my step 3 is my y-intercept. And my y-intercept is the y value when x is 0, which is also 0, negative 3. Now look at what happens here, guys. Do I have a mirror image? Do I have a point that I can do a mirror image for? So now, you either need an extra point or you need to solve. If I told you to solve by graphing, you'd have to solve, but we're not there yet. So right now, I'm just asking you to graph this, make a table, and just solve by finding the x-intercept that's solving. You can absolutely do that if you wanted to. Okay, and then it'd be plus or minus the square root of 3. It's going to be tough to graph that. So what I would do is just make a table. Choose when x is 1. When x is 1, what's y? Negative 2. So 1, negative 2 is right here. What's the mirror image? Yeah, if I went 1 to the right, now go 1 to the left, and voila. You're graphed and you're done. Okay? Now, if I told you to solve, guys, then you have to solve. by either factoring, square root method, completing the square, quadratic formula, which we have already learned. Okay? Does that make sense so far? Okay. Almost done. Okay, let's graph. Let's graph it. F of x equals x squared plus 9 plus 9 plus 8x. First off, guys, always write it in standard form. So this is f of x equals x squared plus 8x plus 9. Now, axis of symmetry. X equals negative b over 2a. So x equals negative 4. Let's graph that sucker. 2, 3, 4. My vertex is my negative b over 2a, and then plug it in. So I've got negative 4 squared plus 8 times negative 4 plus 9. So I've got 16 minus 32 plus 9. So that's negative 16 plus 9, which is negative 7. So negative 4. 1, 2, 3, 4, 5, 6, 7. My y-intercept is 9. So 0, 9. My y-intercept. So I've got 0, 9. And that's 1, 2, 3, 4 to the right. So go 1, 2, 3, 4 to the left. And voila. Done. Now, I want to go ahead and do the x-intercepts just so you can see where this is going. If I wanted to solve this, I can factor this. This is x, x. Oh, actually, no, I cannot factor that. So how can I find the solutions if I can't factor it? Quadratic formula or completing the square. So I'm going to go negative b plus or minus b squared minus 4 times a times c over 2a. So this is going to equal negative 8 plus or minus 64 minus 36 is 28 over 2. So this is negative 8 plus or minus 2 square root of 7 over 2. Now, that's what this point and this point are going to be. Let's verify that we are correct. If I go negative 8 plus 2 times the square root of 7, and I divide that by 2, it gives me negative 1.35. That's about accurate. If I go ahead and say negative 8 minus 2 square root of 7 divided by 2, I get 6.6. 1, 2, 3, 4, 5, 6.6. Pretty darn good. And that's how you graph. Sir, my brother.
So it's that don't reduce once they give you the same answer.
Even if you reduce this to negative 4 plus or minus square root of 7, it's still going to be the same answer. It'd be easier, of course, to reduce if you had to plug it into your calculator. But as far as my tests go, I want those as the solutions. I'm going to know on your graph if you're close or not. These guys right here, oh boy. These guys right here will tell me. Okay? Does that make sense, guys? And last but not least, this is pretty simple. You can figure this out. It says here, determine whether the function has a max or a min. By looking at this, guys, so you're going to have a max or a min. A max because it's positive. No, a min. The a is positive, guys, so it's going to have a minimum. Now, state the maximum or minimum value. Well, to state the maximum or minimum value, I need the vertex. So I've got my, hold on, negative b over 2a, so x equals 2. And my vertex is 2, comma, 4 minus 8 is negative 4 plus 9 is 5. So the max or min, pay attention to this, occurs at the x. So this particular max or min, in this case it's a min, this particular min occurs at x equals 2. But it has a value of y. So the max, the min here occurs at 2, but has a value of 5. Thank you very much. Follow the calendar. Have a great day, and I'll talk to you later. Hope you learned a lot. Bye-bye.